So the last mile logistics is literally like how we serve the final consumer. So it's not about long haul transportation, it's about when, let's say, an e-commerce shipment leaves a warehouse, how it reaches the last mile literally towards the final consumer, to the house of the consumer or to the point of the consumption. Because now we see that more and more players in the industry basically try to adapt such models, try to adapt what we call multi-tiered distribution. So using big vehicles to basically go as far as possible into the city, and then using smaller vehicles like bikes for the final delivery run. And we support actually the design of such systems, again, with quantitative methods to understand where to locate those depots, which and how many bikes to use, how to deploy them, how to route them. This is the kind of work we do. And this is something that the industry is getting increasingly interested in. There are probably two main reasons for that. One is urbanization. So urbanization is a global trend, a very rapidly progressing trend. We see an increasing amount of so-called megacities in the world. At some point, they need to grow in density because they reach like physical boundaries to their geographical expansion. And density is what drives the complexity of the last mile. It creates congestion, it creates uncertainty, random events happening, like for instance, accidents that disrupt the logistics process. And the second trend is e-commerce. E-commerce basically being a trend that you and I probably perceive as something positive. We become, like logistics services become increasingly convenient to us. We can choose time windows, we can choose different speeds of delivery, we can individualize our deliveries when we order from online platforms, for instance, very much. But that leads to fragmentation of shipments. So more and more small shipments need to go into large urban centers. So the number of drops, the number of deliveries increases, and the planning of efficient delivery routes therefore becomes increasingly difficult. The problem about this is that a lot of the large e-commerce players, I don't want to mention names now, but educate the consumer to expect this increase in service level without paying for it. So you and I are probably used to things like free same-day delivery by now, and we don't even think about the cost that the logistics service providers actually incur from providing such fast deliveries. A couple of years ago, companies came to us with a problem that they didn't have the data for. Nowadays, the problem is rather that they come to us with a lot of data and a lot of problems. And the challenge is they don't know which data to use and how to use it to solve their most pressing problems. The work that we do tries to identify the right sources of data for logistics operators or city planners to basically inform their decision making and to use advanced analytical methods. Today we talk a lot about machine learning, optimization, simulation models, to use all those quantitative tools that we as academics have ready to go to basically allow them to make better decisions. Sometimes people think, oh, we need extremely complex and difficult to understand data to make better decisions. That's not necessarily the case. So we can get a lot of valuable information out of seemingly simple data that companies typically have, like for instance, order records or delivery records or customer records. Usually it becomes interesting for us from a logistics point of view if we're able to geo-reference this data. So if we can put different pieces of information on a map and combine them based on their geographical location. So geospatial data is obviously very important for us, and that also relates to movement data. For instance, GPS traces is something that a lot of companies collect of their delivery vehicles, for instance, but don't use. So we try to build tools and analytical models that would help them extract the insight from that data that they didn't do before. We use large amounts of data from the company, we combine it with external pieces of information, and build analytical tools to improve their strategic and operational design and planning of their distribution systems. With regards to the car industry, I guess the most important technology trend that we're right now looking at is probably autonomous technology, be it autonomous vehicles, like terrestrial vehicles, or be it autonomous drones. Depends a bit on the time horizon, I guess. Right now, we don't even see autonomous cars working at a larger scale for passenger transportation And freight transportation comes with additional complications, right? Packages don't think by themselves. Passengers in an autonomous car know when to get out, and they usually get themselves out. Packages don't do that. So even if you have a fleet of autonomous delivery vehicles, you need a lot of additional infrastructure around that fleet to actually make autonomous delivery viable. You need some sort of interface, for instance, between autonomous vehicles for delivery and the buildings or the facilities that are supposed to receive those shipments. So the infrastructure requirements of completely autonomous delivery operations are tremendous. And probably that's even a bigger challenge than making the vehicle itself autonomous. The combination of drone-based delivery with terrestrial vehicles and potentially autonomous vehicles could actually change the logistics landscape quite a bit, because it could combine the benefits of aerial transportation, so drone-based delivery, and the benefits of putting a lot of packages on a truck that moves around on the ground. It combines those benefits and makes logistics processes more efficient in total.